Now, the other type of routing protocol that we have is the link state. Link state routing protocols utilize the network in a much more optimal fashion compared to distance vector routing protocols. And they have three primary characteristics that you need to get used to. First, they normally have a much better metric known as a compound metric, which is a calculation of the cost or bandwidth or delay or whatever the case may be. These metrics are normally much more sensitive to line conditions overall and are considered to be more believable to a router. Therefore, because they are more sensitive to line conditions, they really do understand what the state of the line is, how much delay or load is being pushed across that line, and they can typically make better routing decisions overall. The other thing about a link state routing protocol's sensitivity to line condition is that it really understands the network. It will physically make a map of the network from every router's perspective, which will sometimes take the form of a tree. This helps routers on a network understand all of the possible links to every destination and can therefore typically have much better convergence time anytime there is a fault on the network. But probably the main characteristic of link state protocols is in the way they exchange information. They do not send a predefined interval update, but instead exchange what are commonly known as triggered updates. Every time something on the network changes, it prompts information to be transmitted via the link state routing protocols. These are relatively small updates everywhere and are transmitted only when changes occur on the network. Additionally, since link state protocol forms relationships only between neighboring routers, this information is only shared with related routers. The link state protocols typically utilize an IP multicast direct packet, which does provide lower bandwidth consumption overall on the network as opposed to broadcast communications. The two classic examples of pure link state routing protocols are the Open Shortest Path First, or OSPF, and the Intermediate System to Intermediate System Protocol, or ISIS. These two protocols function in very similar fashion, and they actually look very similar in their architecture, their design, and their communication. Both these protocols have a much better metric than that of a distance vector. As mentioned earlier, the EIGRP is a hybrid protocol that can also be counted as an example of a link state. It establishes neighbor relationships and communicates only with directly connected routers. It also shares a very good compound metric philosophy with link state protocols.